right friends? So I band is present in between the thick filaments of the two adjacent sarcomeres. Here is from here that side sarcomere, from here this side sarcomere. So in between the thick filaments, right, of the two adjacent sarcomeres, this area is shown as isotropic band or I band, right? And the area taken by the thick filament inside the sarcomere, this is called the A band, right? Okay. Now, the proteins which are, I'm talking about these proteins, these are called the titin proteins. Titin proteins, and these titin proteins are the proteins which are connecting, which are stabilizing the thick filament to the M line, which are connecting the thick filament to the M line. So, these are made up of titin proteins, right? Now, another thing, there is thick filament, right, and then there are thin filaments also. So now we will make the structure of the thin filament in this diagram. Now look carefully. Our thin filament is made up of three different types of proteins. Thin filament is made up of structurally three different types of proteins. What are those proteins? Let me make it here. Let us make them there. I hope you can see in the camera. Look, here is a protein which is very important protein. I will name it for you, right? This one, and here also. Like this, right? This is our thin filament. I haven't completed the structure of thin filament. Look, thin filament. So first of all, the thin filament is composed of the straight protein, which is called, this one, the actin protein. This is our actin, and you know this is our actin protein. Around the actin protein, structurally there is arrangement, there is coiling of another protein which is called the G protein or F protein, right? So here I will make the diagram like this, right? Like this. Right? I hope you are understanding the real structure, what I mean. Right? Like this, right? So it will be like this, right? So here the same structure will be found there. So I will make it here. Here I will make it simple, not too much. I will not take too much time of you guys. Like this, right? Now these proteins which are present, right? So look carefully. This protein, right, which is coiled around this actin, right? I will take some small part of it. First of all, it is composed of a small unit like this, right? Small unit like this, and in the central part of the small unit there is a hole. This small unit of this whole ring, this is called the G protein, right? This is called the G actin or G protein or G actin protein, right? And when all these G actins combine, they make the F actin protein, right? So look carefully, they will combine, and these are called, when they combine, these small G actins combine, they make large units, and these large units are called the F actins, right? So F actins and G actins, they will combine and they will make the ring around this actin, right friends? And then what is this ring called? This whole ring is called the actin ring around this this core actin, right? The core actin is surrounded by this G and F actins. Clear friends? And same will be the structure here. Now look, around this F actin or G actin monomers and F actin, there is another protein surrounded. Another protein is surrounding them, right? And this protein is called the Tropomyosin, right friends? This red protein around this G or F actin, this is called the Tropomyosin. Tropomyosin, right? So tropomyosin is surrounding what? It is surrounding the F actin, or we call it the actin. Simply we call it actin. And same will be here, right? This, right? So this is our thin filament. Clear friends? Now inside the core of this actin and tropomyosin, there are small proteins present, small proteins present, which are the active units, which are the calcium binding units of the thin filament, and these are arranged in this manner. They have 2 feet, right? They have 2 feet. I will open them and I will tell you now. These 2 feet, the small protein, I will open and show you the structure of it, and also I will discuss about it while I will discuss about the neuromuscular junction. So some such proteins are found also here. I will show a little bit, not all of them, right? This is called the troponin protein. Which protein? This is the troponin. Let me write his name here. Troponin. So there is tropomyosin, there is actin, and there is troponin. These 3 proteins combine and they make the thin filaments. And same thin filament is found here. Same thin filament will be found here, my friends. So above thin filaments, below thin filaments, above thin filaments, and below thin filaments. So one sarcomere, right? One sarcomere contains full thick filament and half of the thin filament, right? Half of the thin filament has gone into the other sarcomere, and here also into the other sarcomere, right friends? Now here is another protein, right, which is combining this thin filament to this thick filament. So they are arranged like this, right, like this, and here like this, like this, right, and here also. What are these proteins called? I will tell you now. These proteins are the myosin proteins, right, like this, and same will be here also. So if I draw here one, for example, I will draw only one thin filament here, only one, not all the full structure, right? So here is the thin filaments or the myosin, and here will be other myosins, right? So what are these? These are the myosins, and these are also the myosins, right? So myosins combine the thick filament to the thin filament here also, and they are used to bring the 2 Z lines near to each other during contraction. I will discuss about the contraction of the muscles in the next lecture, right? So during contraction, so this is the whole structure of one sarcomere. Now look carefully here, in between the two thin filaments, this small area which is remained in between the two thin filaments, this small area which we have here also, this is called the H zone, right? This is called H zone, right? So H zone is present in between the two thin filaments. Here will be also H zone, here will be also another H zone, right? A band, I band, right? H zone. Okay, so okay, I think we have completed the structure of one sarcomere. So one thing remaining, look carefully. If I take this one troponin protein and write here, so this troponin protein has a head like this. It has a head, and then the head is connected to the neck, and the neck is connected to the tail, right, like this. So this is one troponin protein. This is the head area. Head is towards the thick filament, and this is the neck of it, which contain enzymes and other things, and this is the tail of the myosin filament, right, my friends? Now very simply we discussed about the structure of one sarcomere. One sarcomere is the part of the muscle which is present in between the two Z lines, right? And inside this it has a thick filament and half of the thin filament on each sides, above and below, and on lateral sides also. So muscle is like this, right? So on all sides. Okay, then there is other filament and sarcomere and other sarcomere. All the sarcomeres are connected through these M-line proteins, right? Okay friends, the important points: A band, I band, M line, Z line. What are the meaning of all these? So I will write the meanings of all these here. So the first thing is A. A means anisotropic, right? A means anisotropic band, anisotropic, right? Then there is the I band, number 2. I means isotropic, right? Then there is Z line. Z means number 3. Z means let me write the spelling here first, right? So Z means Zwischen bib band, right? Or line, sorry, Zwischen bib line. And number 4 is the M line. M means middle. M means middle or might, or it means M-I-T-T-E, might, right? And then and other things, friends, what is the length of this thick filament and what is its width? So first, thick filament. These are a little bit details which I wanted to share with you. So thick filament has a length of, what is its length and what is its width? So its length is about 1.6 micrometer, 1.6 micrometer, and its width is about 15 nanometer. 15 nanometer is the width of the thick filament. And about thin filament, what is the thickness of this thin filament and what is the length of the thin filament? So its thickness is about 1.0 micrometer and length is about 8 nanometer wide, right? 8 nanometer is its width. Let me write here width, and this is the length, right? And then there is the H zone also present there. So the length of one sarcomere, what is the length of one sarcomere? So it's about 2.5 micrometer long, 2.5 micrometer. It is the length of one sarcomere inside your muscle tissue, right friends? So these were a little bit details. Now I hope you understood how to draw the structure of one sarcomere. So there are millions of sarcomeres inside one muscle fibril, and they combine, they make muscle fiber, and these fibers combine physical, and physicals combine, they make one muscle. So I hope you understood the structure of one sarcomere, and I hope you can draw it now very easily. I could make it on the board first and then explain it, but no need of that, because you will not understand that from where the teacher has taken the diagram and how he has drawn it. So I have drew every point to make it clear for you guys, so that you can draw it very easily in your copies and your examinations. So this is about the structure of one sarcomere. So next lecture will be inshallah about I will discuss about neuromuscular junction, or I will start discussing about the muscles of upper limb and lower limb and all these. So see you guys in the next lectures. Till then, Allah Hafiz.